Alright, I am back again and we're going to make probably quite a unexciting video. But I've been doing lots of little tiny projects, but they're not quite ready to actually make a video out of. And I'm going to redo my, let's just grab it, this project here, which is meant to be my little game where you have to move the LED backwards and forwards with the buttons. Out of logic ICs, because it's just too complicated that way. So we're just going to do a simplified version for that proof of concept with half the ICs, because if it works then I can make a circuit board later on for it. But anyway, I've been doing some other Arduino projects which I think might be interesting, but I haven't quite got around to finishing them. So I thought we'll look at going back to joysticks again, but we are going to move on, I hope very soon, once I've got everything sorted, has a hint using these things. So we're going to have fun with these, which is a retro computing project, which I'm quite excited about because it's something that I really wanted to get into doing a long time ago. But anyway, this is a Super Nintendo SNES controller, a kind of shabby looking one. It's the only one I had on hand. I'm actually not starting with it, I'm starting with a NES controller, but I don't have a NES controller, a Nintendo Entertainment System controller on hand. But they actually work kind of the same way. This is like double the insides of the of a NES controller. So once you understand how the NES controller works, you'll understand how this works, and vice versa. But that's just for show. Out of interest, of course, they sell these little USB versions all over the show. This one's slightly, the cable keeps coming out. When they use them with kids, they invariably manage to somehow pull the cable out. So I've just got this one to repair. But they're actually quite a good match for the originals. So I think that's kind of interesting. But anyway, the buttons are slightly different, aren't they? These ones here are slightly in the different. They do actually come with a lavender version and a multicolour version. So anyway, so this IC we're going to be looking at today. So we're not actually going to be making the controller tester first. Well, I thought we'll start by making a controller. And of course I've gone and lost a little chip bending thing, which was sitting right on this table not that long ago. But then everything's a bit of a mess at the moment. Well, we don't need the chip thing. We just stuff it in here somewhere. It will go in. That's not going to break it. It's not going to break. Oh, I wish I... There we go. It's in. I don't know if that's the best way around to have it. It is. It'll be fine. What IC is it? It is... Well, the IC that's inside one of these things, I think is... I've forgotten the number now. I think it's a 4027 or a 4021. Where's my little book gone? That would have been handy. As you can tell, I'm not well prepared for this, but if I was well prepared for this, I'd never actually get around to doing the video. So you have to take what you've got. And surprisingly, the book that's always sitting right next to me is no longer sitting right next to me, so I can't actually check. But anyway, what is it? It is kind of the opposite of our old friend, the 74HC165. Which is a parallel to serial converter. So in that case, what you have is I was going to draw a picture, wasn't I? Well, it's not going to happen tonight. We're not going to have any pictures. We could have a picture. Where am I going to draw though? This is very confusing. Alright, we're going to use this one here. Right, that's the 5.9. Sorry, I need that one. We'll use this one here, and we'll draw it here. So on the 74H595, there's my inputs, right? And they go into the IC, and gosh, cables, and then they come out one bit at a time. So they parallel. You have them all going in, and then they get sent out one bit at a time. Wait a moment, that's the opposite way around to what I want. I think. No. They go in. So I've just given the whole thing away, haven't I? So they go in one bit at a time. So you're sending the bits in one at a time. Just to sidetrack so that you don't... where did I put it? I've lost it. This upcoming project here is another use of these are two 74HC595s. So this is a little game So I've got a couple little games inspired by other games coming up. But so in this case, you're putting in bits one at a time, and then they're slowly getting shifted onto the outputs. The opposite way of doing that, of course, would be to bring that back in, is to have all these bits here and then load them into the inside bit and then inside of the IC, and then shift them out one bit at a time, which is exactly how these controllers work. So they work quite differently to a standard Atari joystick, and they work differently to a Sega Mega Drive or Genesis controller. They just work by this process here, which I shouldn't have thrown a piece of paper away, of the inputs being the buttons. They get latched into the inside register of the IC, and then they get shifted out one by one, and that's what goes down the cables on the end here. So I don't know what the pinouts for this is, but this is where did I get this from? I was going to actually make sure I quoted. It's from allpinouts.org. So they had a very brief section on what this is, but this tells you. So I wish I had the SNES control. Oh, I almost could have actually had the actual SNES connector. We're going to get to the SNES connectors soon in the next video. The only way I could get SNES connectors without damaging an actual, not a SNES, you can actually buy I've got a couple of sockets for these things that I could use on a breadboard, so you can buy them for SNES, but the NES controller ones, which are this funny shaped, kind of ugly looking controllers, to be honest, seem to be very hard. Well, I couldn't find them very easily that I could buy cheaply. But you can buy extension cables, so I bought some extension cables, and then you get like one of it. You get a socket and a plug on each end, and then I just chop them up and use it that way. So that's what I've done. So I've got some of those coming up. But as you can see, there's very few things actually used. So there's seven little pins on the connector. One of them's supply voltage, one of them is ground, and then there's a clock, latch, and then there's data out. So there's only these three things here that really are actually doing much. And in fact, that's what they're going to be doing. So they're going to be, you're going to latch this. So this is directly connected to the 4021 at the bottom. Latch in the current state of the buttons, and then clock them out one by one and read them into the computer or whatever. And you're done. Now the thing is, I probably do have some 4021s because I planned to do this video a long time ago, but I don't know where they are. So what we're going to do is we're going to use a slightly different one. We're going to try and see if we can do it with the 74HC165, which is what this IC is. So tonight we're just going to play around with this and see if it works. And then we're going to try and see if it works as a pretend controller for an actual Nintendo Entertainment System. I do have an NES that's not very hard to get to, in a mint condition box actually. It's really nice, quite good. It worked last time I played with it. So we can plug that, and I've got controllers for it and everything. So we can see if we can build a controller first that plugs into the NES, though I might try and build a tester as well at the same time, just so that I don't blow up my. I'm not going to blow up my NES, and I've got quite a few NESs, so it's fine. But anyway, I think the only real difference is, other than the layout of the pins, is that the latch is on a 4021. If I had my little book, I could have a double check. Seriously, it's always sitting there, right near here, staring at me, but not today. Oh, there it is. It is staring at me. Right. Okay. Here we go. Here we go. 4021. Are we actually going to get anywhere in this? Probably not. So 4021. That's what it looks like. These are the parallel inputs. There's your out. This is out 7. Well, that's going to be one interesting thing. Maybe it outputs in the opposite order. No, it won't. It doesn't really matter. We can swap them around. I know there's quite a few outs. That's quite interesting, isn't it? So you've got, you can actually read 3 different bits of the input, 3 different inputs at the same time, which I don't think you can do with the 165. but the clock is an edge triggered one, so I think it's triggered on a rising edge on the latch pulse. So yeah, here when you go from low to high voltage, that latches the inputs, but on here it's latching all the time when it's high, and it's not latching when it's low. So it's serial mode when it's high, and it's serial input mode. You can also use it as a serial buffer, I guess. But that's actually going to be kind of interesting. No, that'll be fine. That will be fine. Or that. So I'm just thinking, well, that might be a slight problem. But then probably what happens inside of the controller is that it goes from low to high, and that's what it thinks is latching it. And that should work fine for here because it's going to be high, and then it's going to be latched. But the only time that it might be a problem is that if this goes from low to high, the actual thing using the controller, it goes from low to high, stays in high while it reads in the buttons through the serial clock, and only goes back down to low when it's finished. If it does that, then it's not going to work with this thing here. So it'll have to be something tricky if that's the case, or I have to actually check if I've got any 4021s. But we'll see how it goes. So first off, we'll get this, and then we'll just try and build this. So we're going to have a bunch of buttons. In the 17 minutes I've got left, I'm going to do this really fast. I've got a bunch of buttons, and I'm not even going to use where did I put it? We're going to use this thing here. So I bought a bunch of little nanos because they're quite small and useful. And this one has been set up. It's got a couple of pins that have got different clocks, different pulses coming through them. So pin 13 is set to basically pulse once every second. So it changes state every half second. So it goes on, off, on, off, on, off. That's what we're going to use today. But a couple of the other ones are for another project, which we're also going to do very soon, which is just going to be looking at a fun IC that I have. That I picked up recently, but again it's going to require slightly more work than I keep getting around to doing, but hopefully, mainly because it requires slightly more voltage than my usual 5-volt shenanigans for some annoying reason. Though I was going to try seeing if it works with 5 volts. Though the specs in the data sheet said that it worked with at least 11 volts. So but then I have this cool little funky special breadboard, not the one that I pulled out a long time ago and haven't ever used, another one, but I will use that other one that I bought out, if anyone remembers that. Alright, so that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So we're going to do, I know exactly how this is going to work. And then we're going to have 1, and we're going to pull them down to ground. Is that what I? No, that's not what I want to do. I want the pulling down to go on the actual IC. So this is the layout of this one here. So there's A, B, C, D, E, F, G, H. Well, that's quite sensible, isn't it? Like, you don't often expect them to be so well laid out, do you? So we will put pull down resistors for all of those. Have I got this the right way around? No, I haven't. It's that way around. Well, that's annoying. No, I'm not going to do that. I want the page this way. So I'm going to take it out. Moving it around. I'm not even sure I have a stock of... I do have some cool stock of wires. So let's do this quick. 1. I really should pre-cut these, shouldn't I? Oh, and they're going to be over there. This is like what would you call it? Like extreme breadboarding. There could be a thing called extreme breadboarding, or what's the word when you're doing it and it's kind of like I can't. think of the word, but it will come to me. I'm going to make sure everything is not touching. That's not touching, it's fine. And the other pins, they're all on exactly the opposite side. So far, this IC wins the award for being the best laid out. So we're going to power everything off this as well. Except smart old me put that. Okay, we'll have to put it over here, which is not so clever. Okay, you're in there. I do have a USB power supply nearby, so we'll be able to power it up. So of course I could power this off the 5 volt, which we might do that actually instead, if we have time. Powering it off the little breadboard power thing. So that one goes there. This is not, I'm not going to get this done in 13 minutes. Alright. Well, that's okay. It's okay if it's more than one, because I'm not making enough videos on this channel. So if I fluff around and this doesn't get finished, and it's like a completely pointless video, all I'm doing is playing with an IC. But we will have fun with Arduino games soon. And I am going to finish my giant IC project with all the little logic, doing another little game. So it's all games at the moment. Maybe I can use this for a game. Come on. Well, if I finish that Tetris game thing, which I'm going to, once I get everything else sorted, we'll be all good. Okay, now we need these little wires. But not this one, because that one's never been opened. And I've got lots of Lego sitting on my desk, so crazy times. And so first off, that one is VCC, so there's my, it's not actually going to, is it going to fit? Alright, that one's going to go like that. And then I somehow have to get, didn't really think about the fact that this is going to require an awful lot of these things. Oh, I don't think I have the patience for plugging. Alright, I have to turn this around. Oh, that's a lost cause, that one. Okay, once you crumple one of the sides, it's just no good. So that was perfect, that one. So that's a good start to the day. That's a pretty good start to the day. We're just going to go through different colors as we go here. I have to also do ground, which is, oh gosh, this is a mess. Alright, well actually we'll space that out a bit. Otherwise, everything is just going to touch and it's going to be horrible. And, alright, I think I should have done the other pins first. But I don't care. But I do have to make more videos because I'm slowly getting more subscribers, like one every so often, and I haven't posted a video in ages, and it's like, oh dear, what have I got myself into? So we'll have to check what all these things are. Oh, right. Oh no, we need that one. Okay. Oh, we need another button. Okay, so this one can be another button. Yeah. And very, very poorly done. And that one can go there. Very clever of me to put that across like that, I think. And so I haven't finished doing this. I'm just doing this all over the show. This one is also going to go to there. So this pin here on here is the latch thing. So this button here is what I'm going to use in a minute once I got these wires out. So I've got a lot of long wires, so we might just have to end up using lots of long wires. I hope I have some short wires. Here's some short wires. I don't think I have enough short wires. Alright, anyway, let's finish this. So you get one. And so we've got my pull downs, then I've got my buttons which are going to pull it up to high voltage, and then we're going to make a flashing LED that you can change the pattern that it flashes with. So I think that's actually going to be one of the coolest things I've ever made. I'm hoping. I need 2 more of these. Okay. So that's that one. Oh, it's not working. It's not. I'm going to ruin it, aren't I? I didn't. No, I didn't. It's not ruined. Okay. And that one is there. So, right. And then, quickly, the first ones can go to here and here and here. I'm just going to take that one off. And I'm not really going, there's not really any point getting this exactly correct. Oh, it's very tricky. Very tricky. I should have put these on first. It's not that tricky. Look at that. They went straight. Oh no, they didn't. Those 2 are out. So looking like that, looking pretty good. We'll just use 4 long ones for the other ones. So I decided that I need to buy lots of long ones, so I bought a lot of long ones. So that's something. But now I don't actually have any of the shorter ones. I think I've run out. And I think this one's wired up wrong. Very annoying. Not that I think at the end I'm going to be able to tell the difference. So, this is frustrating. It's going to, there we go. Okay, and the last one. I'm going to do this. I've got 6 minutes. 6 minutes is a long time when you think about it. So best not to. And then this one has got to go. Oh, I'm never going to get these in. Never. Okay, so far we've got the inputs plugged set up. We've got the latch set up. We now need the clock, which is going to come from pin 13. Which is, where is pin 13 on this thing? What are they? Oh, well, that would be terrible. Like, I didn't think that through, did I? No, I really don't think I did. You can't get pin 13. No. That's pin 13. To be honest, it's very hard to see that. Well, it better be pin 13. Well, we better have an LED. At the moment, I do have a yellow one. I have a red one. Okay. So, I don't have the right kind of thing. What's that? All right. Yes, I'll do that right here. Maybe not. Okay. 1, 2, 3. We need 2 LEDs. So I'll put over the top. So we'll use these giant 1K resistors that I have sitting around for no reason, because you're going to need giant ones for here. So we'll use the red one just to check that the clock is working, because it might not be. And that's going to have, because I know that the little LED on here, because it's connected to pin 13, will in fact show up. But I'm not actually sure that that's pin 13 on the corner, because I never actually use pin 13 on these things. And it's really hard to read in this light. It's not an authentic original whatchamacallit. But I did actually pick up, I can't do it now because I don't have time, so I must concentrate. So this is going to be my serial, which is pin 10, which is this one here. So that's that set up. So we've got the serial. We haven't got the clock inhibit. Oh my gosh, what does that have to be? Clock inhibit. When high, no change in output. Okay, well, we better make that. We better pull that to something else. Alright, so we have to take the clock inhibit, which is, oh, right, okay, when high, we want to pull it low then. So, what have we done? We can tick this off. That one's done, that one's done, that one's done. We don't care about that one. Well, that's the output. I do care about that one. The nice thing about this one is you have an inverted output and a non-inverted output, which is that one there. But we still need, so we've done that one. The clock. Oh no. Wait. No, this is the clock, right? So this has got to go into this one here. So that goes there. And the last one is the serial output. Okay, this is going to take an extra video, I think. Just an extra short video. So we haven't gone too badly. Alright, QH. Oh, that's probably... No, that's what I want to output. Oh no, that's right. I don't want to do anything with the serial. I want QH. That's what I want. So that one can go here. I'm just going to put it over here. Alright, I'll have that one. There. And then we'll have the other one going here. So this is going to be the inverted one. So that will make something that looks pretty. Okay. And then all we need, we still haven't got the most important part done, which is of course powering the whole thing. So I don't know. I think that will do it. I think we'll have to power it from the... It's not going to reach, is it? Oh, great. Okay. Right. And that one goes there. And I forgot. I don't even need that. What am I doing? Don't need that. I don't need those. I can just use these. Oh, there's so much gunk on the end of these things. 1 minute left. Alright, well I'm going to quit the video now and then I'm going to start again and then I'm going to finish it off. So thanks for watching and like, share and subscribe.